Going on now to topic 1.3, they're asking us to write the prime factorization for each of these numbers. Now, in our lesson, we talked about what prime factors were, where the only factors were 1 and the number itself. And the first prime number was 2. So we often use that as we try to figure out prime factorization. So for letter A, we have 27. Now, 27 we know is not even, so we know 2 will not go into it. But if we add the digits of 2 and 7, we get 9. 9 is divisible by 3. So in the rule of threes, if the sum of the digits are divisible by 3, then this is divisible by 3. So we go like this, put our prime 3 out there. 3 times what is 27? Well, 3 times 9. And we know that 9, we can go 3 times 3. So for 1a, it will be 3 times 3 times 3. That is the prime factorization. And for 24, here that's even. So 2 goes into there 12. 2 goes into there 6 times. And then we have a 2 and a 3. So this would be 2 times 2 times 2 times 3. These are the prime factorizations. And I guess that's letter B as opposed to D. And let's do the others, but I'll just do them for you. Okay, here's what we have then. For the 180, again it's even, so you're going to divide by 2. 90, divide by 2. 45, now notice if you add up 4 and 5, it's a 9, it's divisible by 3. So on the outside, we have our prime factorizations. Now the only real tricky one was letter F here, in that we knew we could take a 2 out because it was even, and then since it ended with a 5, we knew we could take a 5 out, and then we got 91. And this took a little bit of finagling here. 7 will go into 91 13 times. So that might have been a tough one to figure out, but you keep trying numbers to see what might go evenly, or what would go into it, never mind evenly. Okay, you can pause this if you need to go back, or we'll just go on, and I will clear it and raise it up a little bit. Now what we want is to write each fraction as an equivalent fraction with a given denominator. Okay, so this is a process, and again we went over this a little bit, but let's look at our strategy here. So our fraction is 2/3, and we want to make an equivalent fraction that has a denominator of 48. Now this is the pattern to get to it. What do I have to multiply 3 by to make it 48? And the answer is 16. Because 3 times 6 is 18. Yeah, that's good. Now, in order to keep this equivalent, I am authorized to multiply something by 1. Well, 16 over 16 equals 1. So I'm multiplying this fraction by 1, but that 1 is in the form of 16 over 16. So that gave me my denominator. Now to get an equivalent numerator, I'm going to go and get 32. So this is the equivalent fraction of 2/3 with the denominator of 48. All right, same procedure. Your fraction is 4/5. I want it to become something with a denominator of 50. Well, what do I multiply the 5 by to make it 50? Well, 10. So I have to multiply my numerator by 10, because 10 over 10 is 1, and that now becomes a 40. And here we have 5/4. We want to make an equivalent fraction with a denominator of 24. Well, 4 times what is 24? 6. So again, 6 over 6 is 1. I'm authorized to do that, so this now becomes 30. Now, just as we multiplied by 1, we can kind of cancel out 1. Now notice 36 is 4 times 9, and 1 times 9 is 9. So I'm sort of factoring that, and now I have 9 over 9 that I can cancel out. So 5 becomes a 4. Now I don't know if you could see it, but 150 goes into 300 evenly. I could divide out 150 and get a 1, divide out 150 out of 300 and get a 2. So this is 1/2. We call this process simplifying each fraction by thinking of it as factors and then canceling out ones, which are the common factors. Now, anytime you divide something by 0, had that reversed. Anytime 0 is divided by something, the answer is always 0. Now, the next one, when we divide anything by 0, here this is a special rule. In our math system, we don't have that defined, so we say that is undefined. Okay, we'll raise it up. Now in number 9, any number that ends with a 0, in a sense, we could divide out the 10. Now we have a 12, which is a 1 and a 2, which is 3. That's divisible by 3. We have a 5 and a 1 that adds up to 6. That's divisible by 3. So theoretically, you can divide each of these by 3. So 3 goes into 12 4 times. 3 goes into there 17 times. So that's that one. Now all numbers are divided by 1. This is something we don't write, but there always is a 1 under any number. So that just becomes 76. Now, when we do multiplication, the rule is, can we cancel out something either vertically or crosswise? And I don't see any common factors here. So this just becomes 2 times 8 is 16 over 27. If you can't cross-cancel something here, then when you end up with their product, you can't cancel anything. Now here, 3 will go into there once, 3 will go into there 7 times, 2 will go into there once, 2 will go into there 33 times. So our product then will be 7 over 33. Now this one, in order to do multiplication, we have to convert from improper fractions, or I should say mixed numbers, to improper fractions. So 7 times 1 is 7, plus 3 is 10 sevens. Now 5 times 2 is 10, plus 4 is 14 fifths. Now that we have it as improper fractions, we can cancel out. 5 will go into there once, 5 goes into there twice, 7 goes into there once, 7 goes into there twice, and we multiply our numerators, which is 4 over 1. We don't write the ones. I'm trying to keep these tapes to around 10 minutes, and I see I've reached 10 minutes already. So on these next few, let's see if we can pick out a few techniques. That here we have a mixed number that we convert to its improper fraction form. 5 times 6 plus 2, there it is, divided by 15 plus 1 over 15. Now this is division of fractions. We always take division of fractions and convert it to a multiplication problem where we take this term and multiply by the reciprocal. That is, just flip it over. Notice now we can cancel out. This becomes 1. This becomes 3. This is a 1. This is a 2. So for number 14, the answer is 6. And here, since our denominators are the same, we just add our numerators, put them over our common denominator, and this can be reduced to that. Now here, this is a 5, this is a 20. Our common denominator will be a 20. So we have to make this an equivalent fraction by multiplying it by 1 in the form of 4 over 4. That's where I get our 16. So this now will become 19 20ths. Now here I set it up in this traditional form, and I need common denominators. So my denominator is 4. I'm just making this a 4, multiplying this by a 2 and a 2. So I get 5/4, which is actually 1 and 1/4. So I'm adding the 1 to the 28 to give me 29, and there's my 1/4. Here for subtraction, we have common denominators. We're just going to subtract 15 minus 3. This is the form I like to use, where we put our numerator over our common denominator. This gives us a 12 that I simplify to 3/4. Now here I need to get common denominators for each of these, which will be 24. So I'm going to multiply this by an 8, multiply this by a 3. So this gives me in the numerator 21 minus 16, which gives me 5/24. And I can't simplify that anymore. Okay, now what I did for number 20 is I took 1 away from the 100 and made it 99 and 5 over 5, which is 1. So this is another way to show 100. Why did I do that? Because I want to subtract this fraction. So now that I have common denominators, this becomes 2/5. And now I can just subtract that nice and easily. And there is my final answer, and that winds up this section. Remember, if you have any questions, bring it to your teacher or tutor, and you can also use the Learning Center at the bottom floor of the library.